Alright, so very good evening to all of you. So I welcome you all on YouTube channel of Unacademy IIT JAM Live. This is your educator Srishti, and in this particular session we'll be discussing some questions on thermodynamics. Okay, so let's start with today's session. So just let me know in the comment section if my voice is clear and the screen is visible. Good evening, Umesh, Bharti. Just let me know in the comment section if my voice is visible and it's clear. Okay, so let's take first question. So I'm hoping everything is fine. So let's take first question, and this is your first question. So this is the first question. Among the following, the intensive properties is or are. So it can be MSQ or MCQ. So you have to figure out the correct answer. Alright, so let's discuss this question. So among the following, the intensive property is or are. So let's start with option D, heat capacity. Okay, so definitely heat capacity is extensive property because it's mass dependent. Okay, let's suppose I take 1 gram of substance and I take 10 gram of substance. Okay, so the amount of energy required to heat this 1 gram of some substance will be definitely less than your 10 gram of substance. Okay, so it's a mass dependent quantity. So definitely heat capacity is your intensive property. Okay. So we can cancel out option D. Now we have to figure out option C. So resistance. Now how we can just write down the formula of resistance. So resistance is equals to rho L by A. This is your resistance. Okay. Resistance is equals to rho L by A. So you can see if I just write, if I increase the length of your substance or wire, or if I decrease the area of your substance or wire, so definitely this affects your resistance of a substance. Okay, so resistance is also extensive property. It's a mass dependent property. Now let's go to option B, electromotive force. Okay, or EMF. So option B is electromotive force or EMF, right? So definitely electromotive force is your intensive property. Okay, it's your intensive property. Let's suppose I take a 10 gram of sample and I take right 1 gram of sample. So definitely EMF of these two samples will remain same. Okay, so it's not mass dependent quantity, it's basically mass independent quantity. Okay, so electromotive force is your intensive property. Then we have molar conductivity. So definitely molar conductivity. The term molar is attached. So this one is also your intensive property. So we have fixed the mass of a substance. So it's for right. It's basically intensive property. Okay. So molar conductivity is intensive property. Electromotive force is intensive property, but not resistance and heat capacity. Okay. I hope this one is clear. Now let's take next one. Okay, so some of you are going with option A, some of you are going with option B and C, some of you are going with option B, C and D. All right. All right, so the question is the following is or are endothermic process. In which of the following cases we have to supply external energy, so that we have to figure out. Okay, so first statement is combustion of methane. So definitely whenever we are combusting any material, so it will give us energy. Okay, so energy is released. Okay, energy is released. Okay, so whenever we are doing combustion of any material, so its amount of energy released per 1 mole of your substrate. Okay, so basically it's your exothermic process. Okay, next is decomposition of water. So you have to decompose water. Okay, so you have to decompose water. This means you have to supply external energy. For decomposition we have to supply external energy. So this means this is also endothermic process. Okay, decomposition of water is endothermic process. Third statement is dehydrogenation of ethane to ethylene. Okay, so we have alkane and we are taking this to alkyne. Okay, so ethane is like this: CH2 CH2 CH3, basically CH3. So we have two carbon carbon bonds and six CH bonds. Okay, so we have one carbon carbon bond and six CH bond. So this is your ethane. Okay, now if this is your ethane, we have to convert this to ethylene. Okay, ethylene is this molecule. Okay, ethylene is basically alkene. Okay, so we have to convert this to ethylene. Now what you can see over here, so how many sigma bonds we have in this case? Come on everyone. 1 2 3 4 5 6. So we have 6 CH sigma bond and 1 CC sigma bond, and in the product side we have 4 CH sigma bond. So 4 CH sigma bond and right, 1 sigma CC bond and 1 pi CC bond. So from 2 CH bonds basically, okay, you have converted this to, from 2 sigma bonds you have formed 1 pi bond. Okay, basically you have formed only one new pi bond. Okay, so from 2 sigma bonds you have formed one pi bond. Okay, so definitely this is not thermodynamic stable process, or this is not spontaneous process. Okay, if this is not spontaneous process, so this must be endothermal. Okay, so this process is basically your endothermic process. Okay, now the next statement is conversion of graphite to diamond. Now which is more stable, which is more thermodynamic stable, right? The graphite or diamond? Definitely graphite is more thermodynamic stable, right? We have learned this thing in main group. So graphite is more stable than diamond, okay? So when you are converting a stable molecule to unstable one, so definitely you have to give external amount of energy, right? So this process is also endothermic in nature, okay? This one is also endothermic in nature. So correct answers are option right, B, C and D. Is it clear to all of you? So B, C and D are your endothermic reactions. From diamond to graphite, definitely this, see, you have to see the process, okay? From diamond to graphite it's not possible, definitely this process is not spontaneous, okay? If you have diamonds, definitely it won't convert to graphite, okay? So we can't define for this system, but graphite is more thermodynamic stable process. So from graphite to diamond, this process is very slow, okay? Okay, so mixed answers for option A and B. Now let's figure out. Okay, let's figure out. So the question is for the process H2O liquid to H2O gas. Okay, and temperature is given, that is 100 degrees Celsius, and P external or P pressure is given as 1 atmospheric pressure. Okay, the correct choices. So now what we can deduce from this information is, first of all, this process is basically your equilibrium process, okay? We can see that temperature is constant and pressure is also constant, so this process is basically your equilibrium process. So H2O liquid to H2O vapor or gas, okay? So this process is your equilibrium process. So we have to find out the correct statement. Now we know for equilibrium process, so can we say this type of process is reversible process? Yes or no? Do you guys agree with this statement? This process is reversible process. Okay. If this process is reversible process, so for reversible process, okay, delta S total should be equals to 0. Can I say this thing? Delta S total should be equals to 0. For irreversible process, definitely delta S total is greater than 0. That means entropy of system increases. But for reversible process, delta S total should be 0. Okay. So now if delta S total is 0, so can I say delta S of system is equals to minus of delta S of surroundings. Then only you can get value 0 for delta S universe or total, right? So if this is the condition, so let's go by this condition. So we can say that delta S system definitely greater than 0, because we are going from liquid to gas, right, transformation. So randomness is increasing, so delta S system is 0. Now in order to make delta total or delta S universe is equals to 0, delta S surroundings should be less than 0. Okay, then only you can get 0 value for delta S universe. Okay, so correct answer is option B. Is it clear to all of you? Any doubts in this question? Is this question clear? So correct answer is option B. Okay, now let's take next question. So what's the question? The standard enthalpies of formation of carbon dioxide gas, H2O liquid, and glucose solid at 25 degrees Celsius are these values, okay, respectively. The standard enthalpy of combustion per gram of glucose at 25 degrees Celsius. So this value you have to calculate. Alright, okay, so let's solve this question. The standard enthalpy of formation of this gas, liquid and glucose is given. So you have to find out the standard enthalpy of combustion per gram of glucose, okay. So now if this is the reaction, we know right, that glucose basically decomposes in your CO2 and water, okay. So this is the balanced reaction, 6C6H12O12O6 plus 6O2 gives you 6 molecules of CO2 plus 6 molecules of H2O. So this is the reaction, okay. And why we have considered this reaction? Because we have to find standard enthalpy of combustion per gram of glucose. So this is your reaction of combustion, okay, per gram of glucose, and this is your reaction C6H12O6 plus 6O2, because this is nothing but your combustion process, okay. If this is your combustion process, so how we can find out the enthalpy? So now enthalpy of combustion, right, enthalpy of combustion is nothing but basically what we have to do, we have to use these values, okay. For CO2 it's 400, okay. So 6 into minus 400, okay, 6 into minus 400, because these are enthalpy of combustions, so definitely product minus reactant, okay. 6 into minus 400 plus 6 into minus 300, okay, yes, right. Then minus of, then what we have to do, we have to take 1 mole, so basically this is minus of 1300, okay. So this is your value of combustion. So now just calculate this value and tell me what answer you're getting. So this is minus 2400 minus 6 into 3 1800 and plus 1300. Right, so this value we are getting, everyone, is it clear? Right, so we are getting minus 2900 kilojoules per mole, okay. So we are getting this value, that is minus 2900 kilojoules per mole. So if this is the value of combustion per mole, okay, so this is the value of combustion per mole. So what we can say, that for 1 mole the value of combustion is minus 2900 kilojoules, okay. So can I say, in 1 mole of glucose, what's the molecular weight of glucose? What is the molecular weight of glucose? 180 gram per mole. Can I say, for 1 mole the molecular weight is 180 grams, okay. So this means for 180 grams the value of combustion is minus 2900 kilojoules. All right, so this is the value. Now for 1, it's asked over here that we have to find out for per gram, basically we have to calculate per gram, okay. So for 1 gram you have to divide this by 180, okay, you have to divide this by 180. Now just tell me what answer you are getting. You must be getting minus 16.1111 kilojoules per mole, okay. See how we can eliminate the option that is also 1 hour, okay. So the standard enthalpy of combustion, so they have asked combustion, okay. So you can cancel out this answer and you can cancel out this answer, because we know enthalpy of combustion comes in negative value, okay. So now we have these two values, minus 290010 kilojoule moles, and we have minus 16.1111 kilojoules per mole, okay. Now if we have less time in exam, or we have to make a smart guess, so definitely we'll go with option C, because this value is too high, okay, and they have asked per gram, so it must be minus 16.1111, right. So is it clear to all of you? Any doubts in this question? Is it clear, guys? Okay, if you have any doubts, you can let me know in the comment section. Meanwhile, we can take the next one. Alright everyone, so what's the correct answer? No issues, okay? I'll be giving you 1 more minute for this question. Okay, so Umesh is going with B. Alright, Sanjana A. Alright, so let's solve this question. So the question is the value of log K for a reaction A giving B. So this is the reaction A to B and it's a reversible process. So what do you have to calculate? We have to calculate log K. Okay. Next is what is given. The reaction enthalpy at 298 Kelvin is given. The entropy is given. R is given. So we have to calculate log K value. Alright. So now whenever all these things are given, so you have to keep this thing in mind that they are basically going with delta G. Okay. So now what is delta G? Delta G is nothing but delta G naught plus RT, right, ln Q. And this is equilibrium process. So at equilibrium, right, at equilibrium basically delta G is equals to delta G naught plus RT, right, ln K, okay, or K equilibrium. Now we know at equilibrium delta G is 0. So what we can write down, delta G naught is basically minus RT ln K. Okay. This is your formula for delta G. Okay. Next is, now we just need to substitute the values and we know this thing that we have to find out this thing. Okay. So that means delta G naught by RT negative. So we have to find out ln K. Now in the question we have to find out log K, okay? So how I can convert this log to ln? We know that this ln is basically 2.303 log, okay? So I can write log over here divided by 2.303, okay? So this thing we have to calculate, okay? Now let's calculate it. So log 10 K is equals to minus delta G naught. Now what is delta G naught? I can write this way. Delta G naught is delta H naught minus T delta S naught. So this is your delta G naught. Okay. So in place of this delta G naught, I can write delta H naught minus T delta S naught. Okay. Negative of this thing divided by 2.303 RT. So this is the thing. Okay. So let's now substitute all the values. So just calculate it, where delta H is given minus 54.07 kilojoules. Temperature is given. Temperature is right 298. Okay, and temperature is 298, and your delta S is basically 10 joules. Okay, so you have to convert this kilojoules to joules, and this is your R value, which is 8.314. So just calculate it and let me know the correct answer. Use all these values and just tell me the correct answer. You have to convert delta H to joules, then it's given, and this value is in joules, so this value is also in joules. Okay, so you just have to use all these values. Alright, so they have given you this thing. See, you can see they have already given you 2.303 into R into T is 5705. So in place of this whole thing, you have to use 5705. Okay, just you have to calculate this value. Just calculate it and tell me the correct answer. So what answer are you getting? Okay, so Akash is going with option A. So all of you are getting 5 as answer. I hope that you have converted delta H to joules, right? It's in kilojoules. Well then, okay, so option A is correct one then. So option 5 is the correct answer. So value of log 10K is 5, okay. Very good all of you. So let's take next one now. This is very straightforward question. The species which by definition has zero standard molar enthalpy of formation at 298 kelvins. Okay, you just have to go with the standard states of these all species. It's very easy, so I'm expecting correct answers from all of you. Right, okay, so at 298 kelvins or at room temperature, Br2 is liquid, right? It has liquid state, and Cl2 is definitely gaseous, okay? And they have asked standard enthalpy of formation. So for H2, it's definitely not equals to 0 because it's a molecule, it's not an element, okay? For elements, basically it's 0. So for CH4 also, it's not equals to 0. So correct answer is option B, okay? Is it clear? Rajendra and Sanjana, is it clear that option B is the correct answer, not CH4, because it's for elements, okay? And CH4 is not an element, it's molecule. So we can prepare molecule that is C plus H2 can give us CH4, okay? So for CH4, the value is not 0, only for B, that is Cl2 gas, right? It's 0, okay? Great. So let's take next one now. Good work, Tarunesh, Sanjana, and Akash. Okay, this one is very simple. The enthalpy of vaporization of liquid is given, and entropy of vaporization is also given. You have to calculate the boiling point. Okay, it's very easy. So, what is delta S of vaporization? It's equals to delta H of vaporization at T. Okay, and this temperature is boiling point. So, basically, this is phase transformation reaction. Okay, if it's phase transformation reaction, so this formula we can use, that is delta H vaporization is equals to delta H vaporization upon boiling point. Okay, it's given that this value is 75 joule per mole per Kelvin, and this value is 3000, right? Basically you have to multiply this by 30,000 joules per mole. Okay, and you have to calculate this temperature. Okay, so this and this will be cancelled out, and you will be getting the correct value, which is option B. Okay, so correct answer is option B, that is 400. Okay, so I hope this one is clear. Yes, okay, so that is Trotton's rule. Basically, what we can do, delta S is nothing but delta H vaporization by boiling point. Okay, this value is nothing but 10R. Okay, so we can equate this value to 10R. We can simply use this value over here, right? So this way also we can find out the boiling point, but it's only valid for vaporization process. Okay, it's only valid for vaporization process, not for a sublimation and your fusion process. Okay, so it's only valid for vaporization process. Okay, so I hope this one is clear now. All right, so now let's solve this question. So some of you are going with A and C. Okay, see, the question is the directed conversion of A to B. The direct conversion of A to B is difficult. Okay, so hence it is carried out by the following shown path. Okay, so delta H from A to C is 50. All right, delta S from C to D is 30. Okay, and delta S from B to D is 20. So can I say that delta S from D to B is minus 20 because it's a path, it's a state function. So it depends on initial and final conditions. So if it's from B to D, it's 20. So from D to B, it should be minus 20. Okay. So this is minus 20. So where EU is the entropy unit, then delta S from A to B. So now it's the state function. So you have to just take the initial values and the final values. Okay. So delta S is now summation of all these three values. So that is 50 plus 30 minus of 20. Okay. So it is 80 minus 20. That is 60 EU. So the correct answer is option A, 60 EU. Clear? Okay. So now you all will be giving the correct reasons for me, right? So now let's solve this question. The question is, which of the following or which of the reaction defines delta H of formation? Okay. So option A, that is C of diamond plus O2 gas gives you CO2. So why this is not correct reaction? Why this is not correct reaction? Just tell me. Why option A is not correct reaction, or why this is not giving you delta H of formation? So what's the reason behind this concept? Right, okay. So the elemental state of carbon is not diamond, it's graphite. Okay. Elemental state of carbon is graphite. Okay. So if elemental state or standard state of carbon is graphite, so definitely this reaction is incorrect because delta HF formation is defined for 1 mole of substance formed from its elemental state. Okay. So now you can cancel out option B. Okay. Right. Now let's go to option C. Okay. Option C is basically N2 gas plus 3H2 gas 2NH3. So this one is also incorrect. What's the reason for this thing? Why this is incorrect option? Yes, come on everyone. Why option C is not delta H formation? Right, okay. So delta H formation is defined for 1 mole of product. Okay, here you can see it's 2 moles So it is defined for 1 mole of product. Okay. So is it clear, Rajendra? Is this point clear? Those of you are going with option C, Bharti, Rajendra, right? Sanjana, is it clear that why option C is incorrect? Because here you are getting 2 moles, okay? You have to just form 1 mole, okay? So option C is incorrect. Then option D, it is also incorrect. Why? Because you should have carbon and oxygen. An elemental state of carbon is carbon graphite, not CO gas. Okay, so this is also incorrect. So option D is also incorrect. So correct one is option B. How? HF is 1, right? So this thing is satisfied. So H2 is the elemental state of hydrogen and F2 gas is standard state of fluorine. Okay, so option B is the correct answer. So is it clear to all of you? These all small questions are very important. Okay, 50% of the students will definitely get this question incorrect. Okay, so all small things are very important. You have to put more focus on these basic things. Okay, now let's take next question. Okay, so all of you are going with option C. Okay, let's find out if option C is correct or not. Okay, so the question is 2 moles of an ideal gas expanded isothermally and reversibly from 1 liters to 10 liters. Okay, so what we can say that in this question, V1 is basically 1 liter and V2 is 10 liter. Okay, and temperature is given, that is 300 kelvins. And what we have to find out? We have to find out enthalpy change. Okay, so can I say that QP is definitely your enthalpy change? Can I say heat at constant pressure is your enthalpy change? Can I use this equation? Is it clear to all of you that QP is your enthalpy change? If QP is your enthalpy change, then delta U is basically Q plus W. If delta U is Q plus W, so this is isothermal process for ideal gas, so delta U must be 0. If delta U is 0, then Q is equals to minus W. And this type of process is your reversible process. Okay. Now the work done is basically minus 2.303. And what is reversible work done? It's basically this thing nRT. Okay, nRT. Then you have log V2 minus V1. Okay, so this way we can find out this heat, and this heat is equals to your delta H. So is it clear to all of you that how we can solve this question? Is it clear all of you that this is how we should solve this question? Okay, fine. So this method of this particular solution is absolutely incorrect. Can anyone tell me why this method is incorrect? Can anyone tell me why this method is incorrect? Yes, I am coming to that point, Akash. I am coming to this thing. Why this method is incorrect? I want reason why we cannot use this type of formula. Any reason why we cannot use this formula? See, we cannot use this formula because in question it's not mentioned that pressure is constant. Okay, it's not mentioned that pressure is constant, so definitely we cannot use this equation. Yes, Tarunesh, I'm coming to that point. Okay, so right, intentionally I'm going with this way so that I can just let you know that what things you have to avoid in exam. Okay, so it's not given in this question that pressure is constant, so definitely this is not the correct formula. Okay, simply what we have to do, we know that delta H is nothing but NCP dt. Okay, we know delta H is nothing but NCP dt, and it's written over here isothermal, so dt is equals to 0, and definitely delta H is equals to 0. Is it clear to all of you? Any doubts? So always for ideal systems and isothermal reversible conditions, delta H is 0. Okay, is it clear? Yes, Seema, definitely it's 0, right? So purposefully I have going with this way so that you can understand your mistake. Okay, so this is not correct. Option C is the correct one. Okay, so have you got this explanation? Any doubts? Okay, so simply you have to use delta H is NCP dt, and this value is 0. So delta H is equals to 0. Okay, great. So now let's take next question. It's very simple. So within 5 seconds, I should get the correct answer. Right, okay, so the correct answer is option D. How? See, delta H is nothing but delta U plus delta NGRT. We know this equation, right? How we can get to this how we can get to this equation? Delta H is equals to delta U plus delta of PV, okay? Now we know ideal gas equation, PV is equals to nRT. Now if I want to make change of this PV, so this is nothing but N is constant, R is constant, delta T. So this is nothing but delta NGRT. At constant temperature, this formula will be delta NGRT, and at constant number of moles, this formula will be NR delta T, right? So using this particular equation, we just have to find out correct number of moles, okay? Now if I want to calculate delta Ng, so delta Ng over here is 2, 1 and 1, that is 0. Delta Ng over here is 1 and 1, 2, right? Basically in this case there is no gaseous species, so definitely we cannot take this thing because delta Ng is 0, okay? In this case 1 and 1, definitely delta Ng is 0, okay? So 2 minus 4, it's minus 2, so if delta Ng is minus 2, so that means delta E is not equals to delta U, right? Basically delta H is not equals to delta E, so correct answer is option D. Again a very simple question, so I should get answers in 30 seconds. A simple one, okay? The delta H formation of CO2, COH2 are given. The standard enthalpy change for the reaction, okay? So you have to find out the standard enthalpy change, okay? So how you can find out the standard enthalpy change? So delta H naught is nothing but, right, this is basically for your product, okay? So for product, it's minus 110.5 for CO, and for H2O, it's basically 241, okay? So you have to just add these two values, minus 241.8 kilojoules. So this is for product minus reactants, okay? And in reactants, you have CO2, and for CO2, it's 393.5. And what you have H2, it's in elemental state, so this is 0, okay? So this thing just you have to do and you can get to the correct answer, okay? So how much value you're getting? Right, so you're getting 41.2, okay? So B is the correct answer. So is it clear to all of you? Any doubts? Is it clear? Any doubts to anyone? Great, okay? So let's take next one. Right. So the question is the difference between heats of reaction at constant pressure and at constant volume for the reaction. Okay. So that means you have to find out QP and QV, right? So you have to just find out the difference of QP and QV, the difference between heats of reaction at constant pressure, right, and constant volume. So you have to find out difference of QP minus QV. Now we know at constant, basically, right, at constant pressure, so this heat is known as delta H, and at constant volume this heat is known as delta U. So what you have to calculate, delta H minus delta U. So this is the final thing. So now we know delta H is equals to delta U plus delta of PV. So this is the ideal gas question. So definitely what I can do, delta U plus delta NGRT. So now if I take delta H minus delta U, that would be equal to delta NGRT, and delta NG is 12 minus 15, so it is minus 3. So this is minus 3 RT, and in place of R you have to use this value because you have to give in kilojoules. So 8.314, and you have to use the standard temperature. Okay, so you can use 298 kelvins divided by 1000, you can get to the correct answer. Okay, so is it clear to all of you? Any doubts to anyone? I hope this question is clear. You can match the answers. The correct one would be right the correct one would be just calculate it. Okay, you can just calculate it. You can just cancel out option B and D. How you can cancel out option B and D? Because you have to find out the difference at constant pressure and temperature, and you are getting this minus sign. If you're getting this minus sign, so definitely you can cancel out option B and D. So now you have to figure out your answer between option A and C. Okay, and option A is your correct answer. Okay, you can solve it and verify this question. And this is the last question, and this is your homework. So what you have to do in this question, okay, so let's take this question. So all this information is given for this question, okay? Or let's do it right now, okay? Let's do it right now. So this is the question and all this information is given, and let's see what you have to calculate, okay? Just read out this given information. So all this information is given at 300 kelvins, and you have to calculate delta S at 300 Kelvin. You have to calculate delta H at 300 Kelvin. First part of this question, second part, and third one is you have to calculate delta S at 320 Kelvin. So these are three parts of this question. 1.5 minutes for this question, and just let me know your answers, okay? So 1 more minute for this question. Okay, so 30 more seconds and then we'll be solving this question. Alright, so let's solve this question. See how we can solve this question. Let's see. Okay, so what we have to calculate, we have to calculate delta H at 300 kelvins, we have to calculate delta S at 300 kelvins, and we have to calculate delta S at 320 kelvins. Okay, so this all value we have to calculate. Now let's solve this question. Okay, for delta H we have to calculate all the information is given over here, right? So delta H is basically you can see this is your product, okay, CH3OH. For this thing, what is the value? Minus 201. Okay, so minus 201 delta H of reaction. So minus 201 for this thing, and for H2 it should be 0, and for CO it's given minus 144. So plus 144. Okay, plus 14. So this value you can calculate. 11 minus 4 is 7, and 17 minus 4 is basically 5. Okay, so this should be minus 57 kilojoules per mole. Okay, so is it clear to all of you? First one is minus 57. Then we have to calculate delta S. Again, this thing we have to repeat. For this thing it's 240, 29, and 240, 29, and your 198. Okay, so 240 we have to do 240 minus 29, but we have 2 moles of hydrogen, so 2 into 29 minus 198. So you can solve this question and you can get to the correct answer. Okay, so next thing is this is at 300 kelvins and this is also at 300 kelvins. Okay, next is you have to calculate at 320 kelvins. So now this is important one and this is some different question. Okay, this is the different part. So in this question, what you have to do, how you can just basically calculate two different things. So you need some values. Okay, you need one equation. So whenever, just remember this thing. Okay, whenever it's given that you have to find out the value at different temperature. Okay, so if you want to find out value of H, let's take an example. You have to find out value of H. Okay, H. So what you can do, so this is basically from Gibbs equation. So you can use delta H2 at basically T2 temperature, delta H2 at T2 minus delta H at T1 is equals to delta Cp of T2 minus T1. So this equation you can use whenever you have to find out delta S. So delta S T2 minus delta S T1 is equals to Cp ln T2 by T1. So this is the equation for delta S, this is for delta H, this is for delta S. And if you want to calculate delta G, so delta H definitely minus delta Ts. Okay, and with this equation you can calculate delta G. So we have to find out delta S at, right, Kirchhoff's equation. Okay, so definitely we have to find delta S at this temperature. So we'll be using this value. We'll be using this equation, that is delta S at T2 minus delta S at T1, Cp delta of Cp ln T2 minus T1. Okay, so T2 is 320, T1 is 300. Right, this value we just calculated that this value is basically your 13. Okay, so you have to calculate, you can calculate it, you are getting basically 13. Okay, so you just have to substitute it, and in this place of delta Cp you can just do calculations and you can find out delta Cp. So what is delta Cp? You can see that this is 44, right, and 44 for hydrogen it's 28.8, so minus 2 into 28.8, and for CO it's 29.4. so this way you can calculate delta Cp. You can substitute over here T2 T1 delta T1 we just calculated at 300 kelvins, and you can find out delta is T2. Okay, so is it clear to all of you? Any doubts? You can solve this question. Okay, you can definitely solve this question and just tell me what value you're getting. Okay, you can solve this question and you'll get the correct answer at delta S at 320 kelvins. Okay, so this is all about this session. I hope you found these questions useful, and right, if you did, you can give a big thumbs up on this session, and I'll see you in the next class, that is tomorrow at 5 p.m. with organometallics question. Okay, great. So just revise these questions. Now you have a good bunch of questions. We just revised approximately 50 to 70 questions in these 3-4 sessions. Okay, 4-5 sessions. So we have revised approximately 50 to 60 questions in these sessions. Okay, so just revise these 50 to 60 questions and some practice more questions on thermochemistry, and that will be the enough. That is enough for your examination. Okay, so I'll see you in the next class. Take care, everyone.